In the heat of combustion of magnesium lab, you're going to take magnesium and hydrochloric acid, and then also magnesium oxide and hydrochloric acid, and you're going to use that information along with an equation that's given to you to determine the heat of combustion for magnesium plus 1/2 oxygen gives you magnesium oxide. So we can't really measure that directly, not in a way that would be safe in the lab, but we can take magnesium oxide, which is a powder, and react that with hydrochloric acid and measure the temperature change, and then we can take magnesium ribbon and hydrochloric acid and measure the temperature change. And then you are given the reaction for hydrogen plus oxygen forms water, and the delta H for that. So we're going to use the information you obtained from your 2 experiments and the reaction that's given to you in order to calculate delta H for this reaction here. So a couple of safety tips. You do have to use hydrochloric acid for both of your reactions, so you want to be careful with that. If you spill any of that on your skin, definitely wash it off immediately and let me know. Also, you don't want to breathe in the magnesium oxide dust, so make sure that you're not getting that too close to your face. So otherwise, you're going to follow your instructions in your procedure. You will use the temperature probe with the LabQuest device, but you don't need to get a graph or anything. You're just going to record the temperature changes. And once you've recorded your temperature changes, then let's talk about what you're going to do with your data. So you're going to calculate the change in temperature for each one of these reactions. And remember, delta T is, my stylus has stopped working on me. Delta T equals the final temperature minus the initial temperature. So you're going to record your final temperature, which will be your highest temperature probably, or possibly your lowest temperature, and your initial temperature, and calculate delta T. So that's step 1 of processing the data. In step 2, you're going to calculate the heat released by each reaction. So we calculate the heat released as Q equals MC delta T. So M is going to be the mass of your hydrochloric acid solution. Oh, come on. Technical issues here. Here we go. Mass of your hydrochloric acid solution. In each case, you're going to measure out 100 milliliters of hydrochloric acid, and the density of this solution is about 1 gram per milliliter. So 100 milliliters, oh come on, with a density of 1 gram per milliliter, we can say that that is approximately 100 grams. C is the specific heat. Since the hydrochloric acid is dissolved in water, or is diluted with water rather, I should say, we can just use the specific heat of water as an approximation, and it's a pretty good approximation given how much of your solution is water. The hydrochloric acid will still not feel very good on your skin if you get it on there, which is why you need to be careful with it. But it's fairly dilute, so for our purposes and calculations, we can say we can use the density of water here. And then you're going to plug in your delta T that you calculated for each one of your reactions, and that's going to give you your heat that is released by each reaction. So then, in step 3, we're going to determine delta H. And delta H can be determined by taking the negative of Q. So you're going to take the Q that you determined, the heat released in the reaction in step 2, and take the negative of that. In step 4, you're going to determine the moles of magnesium and magnesium oxide used. So you're going to convert your grams of magnesium oxide to moles, and you're going to do the same thing with magnesium. Then in step 5, you're going to calculate delta H per mole for both magnesium oxide and for magnesium. Okay. And once you have done that, then you are going to use Hess's law in step 6 you're going to use Hess's law to calculate delta H for reaction 4. And then finally in step 7, you're going to look up the accepted value in your table at the end of your textbook. So if you look in the appendix, you will find a table that has standard heats of formation. And you're going to look up the standard heat of formation for the reaction between magnesium and oxygen to form magnesium oxide. And then you're going to calculate your percent error. So we've done percent error a few times. Remember that we take our measured value minus our true value. And we say true value, but it's really more the accepted value. So you're going to take your measured value minus your true or accepted value, divide it by your true value. And that's going to give you your percent error. Do not be alarmed if you get a large percent error. It happens occasionally. Just remember, if that happens, that be thinking about as you're going along some possible sources of error in this experiment, and think about that when you are writing your lab notebook and when you are writing your written component for this lab. So that is the heat of combustion magnesium lab. Make sure that you have submitted your purpose and procedure on Canvas, and I will see you in lab.